Hello everyone, and welcome to the Mathematecher channel. For today's video, we have a different from zero natural number n. We would like to prove that whatever the value of our different from zero natural number n, the factorial of the number n is always greater than 2 to the power of n minus 1. And for this we will use the proof by induction, which is also known as a recurring reasoning. So before we start, we'll remind that the factorial of a natural number n equals the product of all natural number which are less than or equal to n. As for regards of the proof by induction we'll be using, the principle to follow in order to prove that the factorial of n is greater than 2 to the power of n minus 1, whatever the value of our different from zero natural number n consists of 2 points. First, we'll verify that for the first value of n, which is 1, our inequality, n factorial greater than 2 to the power of n minus 1 is true. And secondly, we'll assume that n factorial is greater than 2 to the power of n minus 1, and use this assumption to prove that n plus 1 factorial is greater than 2 to the power of n plus 1 minus 1, which equals 2 to the power of n. So let's see the proof. So for n equal 1, we have the factorial of 1 which equals 1, greater than 2 to the power of 0, which equals 2 to the power of 1 minus 1. And this means that 1 factorial is greater than 2 to the power of 1 minus 1. We'll note this as assertion 1. Now, if the factorial of the number n is greater than 2 to the power of n minus 1, then if we multiply both sides of this inequality by n plus 1, we find that n plus 1, all multiplied by n factorial, is greater than n plus 1, all multiplied by 2 to the power of n minus 1. Which mean that n plus 1 factorial is greater than n plus 1, all multiplied by 2 to the power of n minus 1. We'll note this result as assertion number 2. Beside that, we know that whatever the value of the natural number n, which is different from 0, n plus 1 is greater than 2. So by multiplying both sides of this inequality by 2 to the power of n minus 1, we find that n plus 1, all multiplied by 2 to the power of n minus 1, is greater than 2 to the power of n minus 1 times 2, which equals 2 to the power of n. We'll note this result as assertion number 3. Now from assertions 2 and 3, and by using the transitivity property of the inequality, we find that n plus 1 factorial is greater than 2 to the power of n. Let's mark this as assertion 4. Now we can notice that in our assertions 1 and 4, we have completed our 2 steps of our proof by induction. So we can deduce that whatever the value of our different from zero natural number n factorial is greater than 2 to the power of n minus 1. As always, thank you for watching. Subscribe to the channel if you're new to it. Like and share the video, and until the next one, have a great time.